Hi everybody, and welcome to the second part of the Solidity tutorials. In this part we're going to work on another simple kind of Solidity smart contract. So I'm going to create a new file on the contracts folder, and I'm going to call this Simple Storage. As you know, Simple Storage in many tutorials is one of the default first tutorials, but we got started with the hello world so that you can better understand it. And then we've gone after the simple storage, which is not much different from the hello world example, but I'm going to cover this because it's one of the most famous examples that the beginners get started. So I'm going to cover that as well in order for you to see that there's nothing fancy about the simple storage. It's just simply saving this. So it's just the same as the hello world. Instead we save a kind of a number instead of a string. So what I'm going to do is to copy and paste the first two lines because they're all the same. So it's the license and the version of Solidity. And now I'm going to write the contract. So just as always, we've got the contract, and then we're going to name this Simple Storage. And then I'm going to open up the bracket, and now I'm going to define or declare our variable. So it's uint 256. So we have different kinds of variables for numbers. We've got int, unsigned int, and with different numbers after them. So with 8, or it could be 8, it could be 16, 32, and up to 256. So you can choose this number based on the number of digits that your data has, or your number has. So anyway, we'll get to that in more complicated tutorials, or in more complex ones. But right now let's consider unsigned int, which is for negative numbers and also positive numbers. And here I can say public because we want to use it someday in the future outside of the contract. If you don't want to do that, you can write private. And then here I'm gonna call this number, right? Or you can say data, whatever you like. And then what I'm going to do is to define a function here, and then set number. So that's the name of the function, and the input is unsigned int 256. And then I'm going to call this new number. So this is exactly the same as what we had in the message, except the fact that here we don't have any constructor. So here we have public, and then we open up the bracket to write the function. So number equals to new number. So we'll get the number from the user. So new number. As you can see, it's just exactly the same as the hello world example. We defined the string, and then we got the new message from the user, and then put it inside of the variable message which we had defined here. So this is exactly the same for the number. Here, this is the way we define number, the type of the number. You can choose any kind of number that you like, whether it's unsigned int or int, or the number of bits it has. So anyway, here I'm going to save this, and if it gets compiled successfully, we're going to deploy it. So now here we can choose which one of our contract we want to deploy. If you have multiple contracts, you can choose between them. Here we've got the simple storage which has been compiled, and so we can deploy it. And once it gets deployed, notice that this is the hello world that had been deployed before, but this is the simple storage. So let's open the simple storage, and so here we can set the number. So this, as you can see, set number is the name of the function. So the function gets an input uint 256. So the name of the variable is new number. So here is where we enter number, and not until we have entered a number we can get the number from here. So if I call this, the number is by default 0 because no number has been entered. So if I enter a number here, so for example 145, and then click on set number, then I call number, as you can see, is 145. So now let us consider another kind of number. So first of all, let me change this to, for example, 8, uint 8, this one too, and save the code. There seems to be a problem here. Okay, let's fix this, save this, and it's been compiled. Now once I delete this one, this deployment, and this one as well, deploy it once again, as you can see, a new simple storage deployment is here, and it says that the number is uint 8. So if I enter a number bigger than uint 8, which is 256, then here we will get kind of error. As you can see, it's not an error, but in Solidity, because we only have 8 bits, and the biggest number it can get is 255, we will face the overflow error, which in Solidity we cannot see that, but in the latest versions of Solidity this overflow problem might have been fixed. But in this version, Pragma Solidity 0.8.0, we still have this problem, right? So if you set the number and get the number, you will see that it's 255. And also let's try this for minus 255, get the number. Oh, it's because it's unsigned int, you cannot see that number, right? It's still 255, and as you can see, it's not being confirmed because the number, as you can see, there is this error and the value out of bound. It says a value out of bound for negative numbers because Solidity has recognized that the number is out of bounds. But if you enter a number like 256, Solidity won't be able to do that. Overflow or out of bound error, and it will show that. Actually here it does. As you can see, the number is 255 again. So in this version of Solidity, actually we have this kind of error, and it won't be a successful one. So here if I enter 255, set the number, as you can see it's been confirmed and there's no error. So actually here, if we have an out of bound number, something bigger than 255, because this is uint 8 bits, which means 2 to the power of 8, which is from 0 to 255. So we'll get that kind of error. But here for 255 we don't have that. So anyway, that's it for the simple storage. And also, if you got familiar with the number and the type of number, and also make sure that we define the number with a suitable kind of declaration, considering that our number might be very big. Also notice that in some of the Ethereum contracts, because we have some very large numbers, 2 to the power of 10 to the power of 18, so it will get a lot of bits, and so we need to manage the number in some way so that we don't get the overflow error. So we will get to those parts, but for now we've learned how to save a simple or put or store a kind of a number in our smart contract, and also update it using the function setNumber. So in the future contracts, we will learn about much more problems that you might face and how to handle them. So that's it for this part of the tutorial, and until the next one, goodbye.